Hello viewers, this is Ronald taking you through this tutorial for A-level mathematics. And in this video, I'm going to talk about the topic of composition and resolution of forces. So this topic is for mechanics and is suitable for students in senior 5 and senior 6 operating principle of mathematics as part of their combination. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. Question 1 who came from UNEB 2019, paper 2, question 15a, and it says the diagram below shows a trapezium ABCD where AD is equal to DC and is equal to CB and is equal to 1 meter. So AD is equal to DC and is equal to CB, and that is equal to 1 meters. AB is equal to 2 meters. Then after that we shall say that forces of magnitude 1 Newton, 3 Newtons, 6 Newtons and 2√3 Newtons act in the directions AD, DC, CB, BA and AC respectively. So the good thing is that they drew for us the sketch of the diagram. So that they say that calculate the magnitude of the resultant force and the angle it makes with side AB. So basically that's what they want, and now let's see how such a question can be answered. So first of all, you shall have to resolve vertically and horizontally. So these are the forces, and now let's see how each was resolved. The first one shows that the horizontal component is -6 and the vertical component is 0. So let's see how that comes about. So if you look at this, six is entirely horizontal and is pointing to the left, therefore implying that the horizontal component will be negative and the vertical component will be 0. So that is why here they wrote -6, 0. Now the second component, the second force is 5, so here we have horizontal is +5 cos 60 degrees and vertical will be -5 sin 60 degrees. Let's see how that one comes about. So if you look at this 5 Newton force, it is inclined at an angle of 60 degrees to the horizontal, implying that the horizontal component will have 5 cos theta and the vertical will have 5 sin theta. But when you analyze it, you realize that to move from point C to point B, horizontally you'll have to move to the right, which is positive, but vertically you'll have to move vertically downwards, which will be negative. So that explains why they put +5 cos 60 and -5 sin 60 degrees. Now we shall go to the 3 Newton force. For the 3 Newton force, we have 3 and 0, and let's see how it comes about. So when you look at the 3 Newton force, it is entirely horizontal and is pointing to the right, meaning it will be +3 and 0. +3 will be the horizontal component and 0 will be the vertical component. So we are done with this. Now next will be the 1 Newton force. Here we have 1 cos 60 degrees and 1 sin 60 degrees. All are positive. So when you look at this 1 Newton force, you realize that it's inclined at an angle of 60 degrees. So from here to here, 60 degrees to the horizontal, implying that the horizontal component will have 1 cos 60 and vertical will have 1 sin 60. But when you look at it, to move from point A to point B, horizontally you'll have to move towards the right, which is positive, and vertically you'll have to move upwards, which is also positive. So that explains why all were positive here. Now we shall go to the 2 root 3 Newton force. So here we have 2 root 3 cos 30 and 2 root 3 sin 30, all are positive. Let's see how they come about. So if you look at this 2 root 3 Newton force, it is inclined at an angle of 30 degrees to the horizontal, implying that the horizontal component will have 2 root 3 cos 30 and vertical will have 2 root 3 sin 30. Then now that you realize that if I want to move from point C to from point A to point C, horizontally it will be to the right, which is positive, and vertically it will be upwards, which is also positive. So that explains why both were positive here. So now that you have finished resolving all the forces, next is to add. We are going to start by adding all the values in the first row, then followed by values in the second row. So when I add all the values in the first row, I'll come up with positive 3, and when I add all the values in the second row, I'll come up with negative root 3. So now that I've got the components of the resultant force, I can get the magnitude of the resultant force by squaring the horizontal component plus squaring the vertical component, everything under square root, to come up with 3.4641 newtons. But remember, they also ask for the direction, for the angle it makes with side AB. So what I'm going to do, I have to first draw a sketch diagram. So horizontally it was positive, meaning it is going to the right. That is why I put here now 3 Newton force. Then vertically it was negative, meaning it from here it has to go downwards, and there I'll come and put an arrow going downwards to put there 3 root 3 Newton, which is that. Now next is to draw the resultant. Resultant has to be from start to end, so that will be the resultant from start to end, and I'll put arrows to show the direction of the resultant. And now this will be the angle which they want us to calculate. So I'll come and say that the good thing is this is now a right angle triangle with opposite root 3 and adjacent 3. Therefore I can now come and get my tan theta from tan theta being equal to root 3 over 3. When I use the calculator, I come up with theta being equal to 30 degrees. Therefore I'll come and conclude that the resultant force is 3.4641 Newton, and the angle it makes with the with side AB is 30 degrees below AB. It is below AB because of this, because you see this theta is below this horizontal, and also our side AB was horizontal. So basically that's what they wanted, and now let's see how much can be awarded. So M1 is for resolving horizontally, so all these values in the first row have to be correct for you to get that M1. Another M1 is for resolving vertically, meaning all these values in the second row have to be correct for you to get that M1. Then B1 is for addition, so adding correctly to get the vertical and horizontal component, you'll get yourself there B1. Then this M1 is for substituting the formula to get magnitude, and A1 is for the final output to 4 decimal places. And lastly, B1 is for the direction or the angle it makes with the side AB. So basically that's how the 5 marks could come the 6 marks could come about. So now we shall go to question 2. Question 2 came from UNEB 2000, paper 2, question 16a, and it says 6 forces 9, 5, 3, 7, 3, 1, and 4 act along the sides P2, QR, RS, ST, and TU, ST, TU, and UP of a regular hexagon. Know that word, regular hexagon, of sides 2 meters. their directions being indicated by the order of the letters. So know that word, order of the letters. Taking P2 as the reference axis, so in this case I've specified which one to be the reference axis. Express each of the forces in vector form. Then after that they said, hence find the magnitude and direction of the resultant of the forces. So the first thing to do is to make a sketch of our hexagon. Then after that we have to label, but labeling has to be done in an anti-clockwise direction. So always remember that labeling has to be done in an anti-clockwise direction like that. So P2, they said P2 is our reference axis, that is why it is horizontal. So P2 RST U. So labeling has to be done in an anti-clockwise direction. After that we shall now start labeling the forces. If you look at this, P2 corresponds with 9 newtons, so that is why we put here 9 newtons in the direction from P to Q. Then in the direction from Q to R, it corresponds to 5 Newton force. So we shall come here and say that in the direction Q to R, we shall put 5 Newton force. Then the direction RS corresponds to 7 Newton force. So we shall come at the direction RS to put there the 7 Newton force. Then the direction ST corresponds to 3 Newton force, so we shall come at direction ST and put 3 Newton force. Direction TU corresponds to 1 Newton force, and direction UP corresponds to 4 Newton force. So TU is 1 and UP is 4. So basically that's what was given in the question. And now they ask that taking P2 as the reference axis, express each of the forces in vector form. So next is now to express the forces in vector form. But before we express the forces in vector form, we have to show the angles to which these forces are inclined to. So for a regular hexagon, those angles will be 60 degrees each. Remember, regular hexagon, the interior angle sum is got by 180 in brackets to n minus 2, where n is the number of sides. So 180 times 6 minus 2, it will be 180 times 4 to come up with 720 degrees. Now 720 degrees is the interior angle sum of a regular hexagon, but the regular hexagon has 6 vertices. So 720 divided by 6 will come up with 120, and that is why if this is 120, if this is 120, it implies that the remaining part will be 60 degrees. Same applies to this 120, this will be 60 degrees. So that is where the 60 degrees is coming from. So now that I've got the angles to the horizontal to which these forces are inclined, I can now go ahead to get the forces in vector form. I'll start with the 9 Newton force. 9 Newton force is entirely horizontal, meaning it will be the vertical component, horizontal component will be positive 9 and vertical component will be 0. Next is QR. QR is inclined at an angle of 630 degrees to the horizontal, meaning the horizontal component will be 5 cos 60 degrees and vertical will be 5 sin 60 degrees. Now if you look at that QR, to move from Q to R, I'll move horizontal, I'll move to the right, and vertical I'll move upwards, so that is why they are both positive here. The next is RS, 7 Newton force. So 7 Newton force, horizontal I'll move to the left and vertical I'll move upwards. That means that horizontal it will be negative, vertical it will be positive, so that is why there is a negative here and here it is positive. Next is the 3 Newton force. For the 3 Newton force is entirely horizontal, but it's going to the left, meaning horizontal will be negative 3 and vertical will be 0. The next is the 1 Newton force. 1 Newton force is inclined at an angle of 60 degrees to the horizontal. So horizontal it will be to the left, which is negative, and vertical it will also be downwards, which is negative. So that explains why both have negative signs. And lastly is the 4 Newton force. For the 4 Newton force, horizontally it is to the left, sorry, to the right, which is positive, and vertically it is downwards, which is negative. So that is why horizontal component is positive and vertical component is negative. So that is what they wanted in the part of expressing the forces in vector form. Now we shall go to the hence part, where they want us to find the magnitude and direction of the resultant of the forces. So for the resultant, we shall have to add all the forces we have calculated above in vector form, and when I add, I'll come up with horizontal component being equal to 6.5 and vertical component being equal to 3.5 root 3. So with that, I'll be able to get the magnitude, which will be square of the horizontal component and square of the vertical component, which will be this everything under square root, to come up with my magnitude being equal to 8.8882 newtons. So they also want the direction, so I shall have to first draw a sketch. So horizontal component is positive, meaning it will be to the right, as you see it here. Then where it stops, that's where the vertical component starts from, and the vertical component is also positive, meaning it will point upwards. Then from start to end, that will be our resultant, but it has to be drawn using a ruler. So I'll draw that and put my arrows to show the direction. Then that will be my resultant force. So to get the angle, I have to calculate this angle to get the direction. So I'll come and put there an angle being equal to theta. So the good thing, I've got a right angle triangle with opposite being equal to 3.5 root 3 and adjacent being equal to 6.5. Therefore I can use tan and come and say that tan theta is equal to 3.5 root 3 over 6.5. Therefore my theta will be equal to 43.0039 degrees. Now I'll come and conclude that the magnitude of the resultant force is 8.8882 newtons, acting in the direction 43.0039 degrees with pitch upwards. I think we can say that, remember, pitch was horizontal and this is our horizontal, so this angle is above the horizontal, that's why you put here upwards. So basically that's what they wanted, and now let's see how marks can be awarded. So we'll start with the part for converting in vector form. For this case, B1 will be for the first three. So this first PQ, QR, and RS, all those correct will give you this B1. Then another B1 will be for the last three. So all these three forces, ST, TU, and UP in vector form, that's how you could get your second B1. Then for this slide, B1 will be for the addition and output. So for you to get this, that will be your B1. Then M1 is for substituting the formula for magnitude, and A1 is for the output to 4 decimal places. Then B1 is for the direction, or to 4 decimal places. So basically that's how these 6 marks could come about. Now shall go to question 3. Question 3 came from UNEB 2010, paper 2, question 13a, and it says, the center of a regular hexagon ABCDEF of sides 2a meters is O. Forces of magnitude 4, S, T, 1, 7, and 3 act alongside AB, BC, CD, DE, EF, and FA respectively. Their directions are in the order of the letters. Given that the resultant of these 6 forces is of magnitude 2 root 3, acting in a direction perpendicular to BC, you know that word, direction perpendicular to BC, determine the values of S and T. So the first thing to do is to make a sketch of the regular hexagon. Regular hexagon means that all sides are equal. After that we shall label, but labeling has to be done in an anti-clockwise direction. Now instead of, I think we realize that we have not started with A here because in the question they told us, if you look at the question, they told us that the magnitude is acting in the direction perpendicular to BC, so that means that BC will be horizontal and this magnitude will now be the vertical. So from there we shall now put the forces. So the forces are so 4 Newton forces for AB, S is for BC, T is for CD, 1 is for DE, 7 is for EF, and 3 is for FA. So let's put all those forces there. So basically those are the forces, and now next is to put the angles. The angles, we put them so that you can easily resolve. Okay, so now that the angles are there, we shall come and say that now the vector sum of all the forces will be equal to the resultant force in vector form. So when you add all these forces in vector form, what you will get will be equal to the resultant force also in vector form. When you do that, we shall come and write so for the 4 Newton force, horizontally it is to the right, which is positive, and vertically is downwards, which is negative. So that's why there is positive here and negative here. For the S is entirely horizontal, that is why it is S0. Then T, horizontally it is to the right and vertically it is upwards, so both will be positive. For 1, horizontally it will be to the left and vertically it will be upwards, so horizontal will be negative and vertical will be positive. 7 is entirely horizontal and it's moving to the left, making it negative 0, so negative 7 and 0. 3 horizontally is to the left and vertically is downwards, meaning both will be negative. Then for the resultant they said is perpendicular to BC. So if this is BC, then perpendicular will be in that direction because they have to originate from a common point. Therefore, this means that it's entirely vertical, and therefore horizontal will be 0 and vertical will be 2 root 3. So now that I've got that, I'll use the calculator to simplify, to collect like terms of all these forces for in row 1 and also the ones in row 2. So when I do that, I'll come up with row 1, it will be S minus 7 plus T cos 60 degrees, and vertical, and row 2 will be T minus 6 in brackets, then multiply by sine 60 degrees. For the other side it will be the same, 0 and 2 root 3. So next is now to equate. So when I equate the vertical components, it means that I'll come out here and I'll first equate the vertical component. So when you come here, the vertical component is this one. So T minus 6 in brackets sine 60 will be equated to 2 root 3. And when I do that, I'll come up with this statement, and I have to simplify until I make t the subject. So I'll come up with t being equal to 10. After that, I'll also come and equate the horizontal components of the force. So the horizontal component will be s minus 7 plus t cos 60 degrees being equal to 0. So I'll come and equate to 0, then I'll simplify to make s the subject. So I'll come up with s being equal to 2. So basically that's what they wanted in this question, and now let's see how marks can be awarded. So M1 is for resolving horizontally and on the left hand side. So all these values have to be correct for you to get that M1. The another M1 is for resolving vertically for the left hand side. So all these values have to be correct for you to get that second M1. Then another M1 is for you to equate to the resultant. So remember, we are given the resultant, so for you to equate, that is another M1. So basically that is how the 3 marks could come about in that part, on that slide. Now let's go to the next slide. For the next slide, M1 is for equating to the components. So but remember, they saw that it's mobile. Mobile means this M1 can be put at this step, or it can be put at this step. So A1 is for you to get the value of t, and another A1 is for you to get the value of s. So basically that's how the 6 marks could come about. So that brings us to the end of this lesson. Be reminded that the next video will be now on parallelogram of forces, still under mechanics. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when this video has been uploaded. Otherwise, thank you for watching, and also if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.